great time to do it. So let's just work our way through things, right? What they were hoping for here is for you to see that the area A is really an area that you know, which is the area of a circle, right? Minus, let's call it green. I need to calibrate this before I do that again. Okay, so there is this, I actually want to make that larger. I'm going to make it larger so that we can. Do you see how if I'm sweeping through, starting at the pole, and I'm going out to the blue up until that line, up until that certain theta value that's represented in green? Abby, do you see that? Oh, good. And then all of a sudden it switches to that red that is being swept out. Do you all see that? So it's not, so this shape that I have the green and red in, to exaggerate it a little bit, is like that. And so this green line is right there. And so what I'm saying is you're sweeping out until you get to that green theta value, and then it switches, and then you're sweeping the rest right there. So this one is the one that's like the pinkish color, and this was the one that was the, actually that one's bluish color. Right? Do you all see how this is a representation of what we have going on there? And so the area of A is going to be based on a few different things. So the area of A is equal to pi times r squared. What's the radius of that circle? 2. Minus whatever's going on there. Right? Does that make sense? And so let's only deal with that part, and then we can see that the bottom half is going to be the same. So this is going to be the same area as that up there. Can you guys see that? Okay. So what we're going to do is we're going to find the area of the green, and then we're going to find the area of the red, and then we're going to double that, double each of those, and then take 4 pi minus whatever that is, because that's what the portion that needs to be removed from the initial circle. How many of you are with me so far? Like, what I just said makes sense? Okay. If you didn't raise your hand, I bet it's because you weren't actively listening. So let me say it one more time, and I'm going to get up here. So what we're doing is we're finding this whole area of the entire circle that's within the pink. Minus, now what I'm saying is if I have that green and then I find that red and then I double that, then that's going to be the whole region that needs to be removed from the big pink circle. And so I'm going to take the area of the big pink circle minus twice that, and also I'm going to minus twice that, because that is double there and that is double there. And then that's going to give me the whole thing minus what needs to be cut out, and I'm going to be left with the area of just the orangish or tannish, whatever shaded region that they call A. How many of you were able to follow my logic there? Okay, so now let's look at that green little portion. What's that green little portion? Well, first of all, what we need to do is we need to find this theta value. How could we find that theta value? Yeah?
So wherever the two circles intersect.
Correct. But how do I find that?
Find an equation for both circles and set them equal to each other.
So you're setting the r's equal to each other, which is only half of what I'm looking for. But let's talk about that. If I have that the r values are exactly equal, so you're setting the r's equal to each other, am I guaranteeing that these guys will intersect? If they have the same r values? No, because one could have an r value of 1 and be, let's say, up here, while the other one has an r value of 1, but that's only true over here. So the r value has to be equal along with the theta value. Or couldn't I have the negative r value with the opposite theta value, meaning you add or subtract pi to theta value? And I've lost you. Right? Mm-hmm. Okay. This is a difficult thing to understand at first, but then you'll see what we got going on. So first of all, let me choose another example, and I'm just going to make this up. Man, I wish I had. Okay. So let's say that right here, r equals 1. Just right there. This is 1 unit. Well, let's say that this other one, when theta is equal to 0, my r value is actually negative. Right? Now here, at this theta value, because, so let's say that when theta equals 0, this guy is a negative r value. So this r value is still negative, still negative, still negative. So this guy is going to intersect there. It's when really the theta value is over here, but the r value is negative 1, and then that would put it at that same spot because of how polar works. Did that make sense? So either you set the r values equal to each other and solve for theta, or sometimes you set the r value equal to the negative r value and solve for theta. Okay? Now, for this one, it's going to work out nicely where we just set the r values equal to each other and go. So let's do that. So 4 cosine theta equals 1. Do you see that? So let's call this r sub 1, and we'll call this r sub 2. So I'm setting r sub 1 equal to r sub 2, and let's solve for theta. Divide by 4, divide by 4. So cosine theta equals 1/4. So when you take arc cosine on both sides, you get that theta is equal to, somebody do that for me. What's arc cosine of pi over 4 that is in the first quadrant, meaning a gradient value in between 0 and 1.57. 1 point, say it again. 318. So I'm going to say approximately. So that's my theta 1 value. Okay? So now given that, how would you use that information? Because we're also using the fact that this is theta equals 0. How would you use that information, now that you know what that theta 1 value is, to get the area swept through of that polar equation? R sub 2 equals 1. What would you do if you wanted to use calculus? I know that that's just going to be a sector, so you can go back to 1/2 r squared times theta. But what if I wanted to use calculus? Yes? Right, so what would that integral look like? Yeah, so really what I would do in my calculator, I would store that as like alpha A, so whatever. And really I would keep writing, so it was 1.318, go ahead and give it to me. Out further decimals. Hold on one sec. Give it to me for further decimals.
116072.
Okay, so that's what I would do, and then I would store that in my calculator as that, and then I would call that whatever, like alpha or whatever you want to. Sorry, go for it, Marcus.
Why couldn't the bottom limit be negative 1.318?
Yeah, so what you want to do is you want to give this whole thing.
Yeah.
What I'm saying is, what I'm doing is I'm going from there to there, and then I'm going to double whatever I get there because that's symmetric. So you could do that. It's not why couldn't you? You could. I'm opting to find half of that and then double that and then subtract that whole thing from the initial. Okay? Okay, so it's 1/2 integral from 0 to that alpha, or theta 1 value, of what? R squared, so it's 1 squared, and then d theta. There you go. This is my integral for only one of those green regions. I know that there are two that need to be subtracted off, right? But this is only one. And then let's talk about red. So I already know that this is going to be 1/2 times the integral from alpha to something of 1 d theta, right? So all I need to know is when that's going to hit the pole. So when the red, because I was going out to the blue here. Oh, sorry, so it's not 1. Sorry. This is going to be 4 cosine theta quantity squared d theta. There we go, right? Because now for the green, I was going out to the blue, which was the r sub 2, which is just 1. Now I'm going out to the red or pinkish one, right? And so that's going to be 1/2 times the integral from that same alpha value to that r, which is 4 cosine theta, quantity squared, because that's the formula, 1/2 integral from alpha to beta of r squared d theta. And so now the question is, where does this hit the pole? So where does that hit the pole? How am I going to find my theta value when that hits the pole? Yeah?
Set it equal to 0?
Set r sub, that's a 1, r sub 1 equal to 0. So I would set 4 cosine theta equals 0. So that's going to be cosine theta equals 0. So for what theta values is cosine equal to 0? Pi over 2, 3 pi over 2, whatever.